So we're sort of moving on now from like the SOHCAHTOA sine law, cosine law, and we're going to talk about the answer for any angle from 0 degrees to 360 degrees. So instead of looking at it only in a right angle triangle, which is 90 degrees, we are going to take that right angle triangle and we're now going to draw it in multiple different quadrants, and we're going to try to solve questions on that. Now, this idea is actually super long. We're going to do it all this week. So we're going to introduce it today. Then on Tuesday, Wednesday, Thursday, we're actually going to go into calculations. I like to do this very, very slowly because it can be a little confusing. So if we take our time with it, it makes a lot more sense. I do want to review, and I erased it on the board, but I'll write it down again. We learned something called reciprocal trig ratios and special angles, and there's going to be a quiz on that on Thursday of this week, and that quiz will not allow you to use a calculator. So you will have to memorize your special angles and then use those. Let's just start talking about reciprocal. So if we have sine theta, cos theta, and tan theta, and we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, what is the reciprocal ratio to sine theta? You just say it out loud. Sorry, I heard it. Yeah, h over o, and it's going to be cosecant theta is equal to h over o. How about the one related to cosine? Secant theta is equal to h over a, and the easiest one is the one related to tan, which is cotangent theta is equal to adjacent over opposite. Another way to think about these is also cosecant theta can be 1 over sine theta. Depending on the information the question gives you, you can use either or. Secant theta is 1 over cos theta, and cotangent theta is 1 over tan theta. Okay. And then the second thing we learned after this were all of our special angles. So hopefully you guys have memorized them, but really quickly, and by the way, we use both of these concepts quite a bit this entire week. So the first triangle is the one that has the same side length. So this is 1, 1, and root 2. And do you guys remember what angles go inside of these? Yep. Perfect. So this is going to be 45 degrees and 45 degrees. The other one is called the 1, 2, root 3 triangle. So 2 is the largest side length. It's going to be the hypotenuse. And then it doesn't matter where you write the rest. So you can go 1 and root 3. And I always remember that between 1 and 2 is going to be 60 degrees and then 30 degrees. And so once you have these memorized, you can basically answer any question dealing with these types of triangles. Okay, so quiz on all of this stuff on Thursday, but we'll also need it for the lesson today. Today's lesson is mostly theoretical, which means you actually don't need to write down much. It's not calculations. We're just going to think about the concept. So first of all, I don't know if you remember this from grade whenever you learned it, but we are going to label our quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So make sure you remember quadrant 1 is in the top right corner. Because we're talking about 360 degrees, there's a specific way we're also going to be labeling our degrees. We start with 0 degrees on the x-axis. So the right-hand side is 0 degrees. And then we're going to go in a clockwise direction and label every 90 degrees from there. So this is 90 degrees. And that makes sense, right? Because it makes a right angle triangle. We add another 90 degrees to get to 180. Does this make sense? Because remember when we learned a straight line, how many degrees are in a straight line? 180, exactly. So technically from measuring from there to there, it gives you 180. Then if you add another 90 degrees to 180, you get 270. And if you add another 90 degrees to 270, you get a full circle of 360. So we're going to be labeling it 0, 90, 180, 270, and 360. Okay, so that's how to label our angles. And how are we actually going to draw our angles? Like when I say, okay, go ahead and draw 87 degrees or 97, we don't need a protractor. It's just going to be a sketch. But what we're going to remember is our angles are always drawn for something called the initial arm. And we're not going to draw the actual initial arm, but you're going to remember that it's always there. And then from the initial arm, you crank it until whatever the number says. So if it's between 0 and 90, then you're going to draw your terminal arm somewhere in between there. If I gave you something like 210, well, that's going to be between these two numbers. So you would draw it somewhere like this. So it doesn't have to be the most accurate. You're just kind of guesstimating and you're sketching it out that way. We're going to talk more about how to sketch it in a second, but just remember these words so I can ask you like definitions about terminal arm and initial arm, or they're good like matching questions. So just remember all the the terms we're learning. Whenever you draw an initial arm and a terminal arm, the angle that goes in between there is called the principal angle. So the principal angle theta is between the initial arm and the terminal arm of an angle in standard position, and it is the angle of rotation. And we'll do a couple of questions with that in a second. Now, because we know if you go in the clockwise or in the counterclockwise direction, it's positive angles, we also have to talk about negative angles. And that is the diagram on the right-hand side. So I'll walk you through that one as well. It's the same concept. We start at 0 degrees, but now instead of going counterclockwise, we're going to go clockwise. This is negative 90. This is negative 180, negative 270, and negative 360. And everything is done sort of opposite. So you still have your initial arm on the x-axis, but now if I gave you an angle like negative 60, from that initial arm, you would rotate down. So positive angles, you start there and you rotate up. Negative angles, you start there and you rotate down. Okay, so this angle right here would be like negative 60. You would label this theta, and it's your principal angle. So a reminder, positive angles are counterclockwise and negative angles are clockwise. Just somewhere on your sheet, because I know I didn't give you a lot of room, let's just practice doing an example of that. So let's say I told you to draw the angle 100, I'm kind of sick of this color. Let's go into this ones. Let's say I said, draw 195 degrees. It's just a sketch. Okay, so the first thing we would do is we would draw our XY plane. We would remember that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And just for practice, let's also practice labeling the angles. So we start, because this is a positive angle, we always start at 0 degrees, but we're going to go counterclockwise. So 0 degrees, 90 degrees, 180, 270, and then we're back to 360 degrees. To label 195, we're going to start with the initial arm. And like I said, you don't have to draw this, but maybe just when you're starting off, you can. And then I know 195 has to be in which quadrant? 1, 2, 3, or 4? It has to be in quadrant 3. And you want to be like maybe just a little bit accurate. Like you don't want to draw it too close to 270 because that doesn't make any sense. It's going to be a little bit closer to 180. So that's what it's going to look like. How do you draw your theta or your principal angle? You start at the initial, you swing all the way around, and you call this theta. So that is your sort of your angle of rotation, or also known as your principal angle. Okay, now what if I gave you a negative angle? Unfortunately, you can't use the same grid, right? Because our negative angles are measured differently. So you might have to draw this again. I'm just going to erase this stuff and just draw it on the same grid. I'm going to start at 0 degrees, and then I'm going to go to negative 90 down here, then negative 180, then negative 270, then negative 360 degrees. And I didn't give us an actual number. Let's say I want negative 305 degrees drawn. Okay, so you still start at the initial arm. The starting point is the same. And by the way, the quadrant, the way you label your quadrants does not change even though you're going in the opposite direction. So it's still quadrant 1, 2, 3, and 4. You're just the direction is changing. So which quadrant is negative 305 degrees going to land? Yep. Quadrant. Yes, because look, you're starting here and then you're basically traveling negative 90, then you're going negative 180, negative 270, and negative 305 is actually going to be somewhere here. And the way that you're going to draw your angle is you start at the initial arm and you're going in a clockwise direction for your negative principal angle. And yeah, I know you're tempted to change like the way you label your quadrants, but that stays the same. So it's a little bit weird, but it's still going to be quadrant 1. Does this make sense? Okay, so this is the basic idea of what we're going to be doing all of this week. We're going to do a little bit more before we stop. Let's talk about the trigonometric ratios of a principal angle. So whenever you draw your angle, you're also going to draw a little triangle to go with it. So in both of these examples where I was drawing our angle, whenever you're done drawing it, you're going to make this into a triangle. And it's a very specific way to make it into a triangle, which we're going to learn about for this week. Let's say our angle looks like that. We have drawn a terminal arm over here. What we do with that terminal arm is we make a little triangle that looks like this. Now, how exactly did we know the triangle goes in that direction and not that in the other direction? Well, I use something called, and you're gonna get so sick of me saying this, but I call it the bow tie shape. So I draw a little bow tie on the side of my page, and I remember that whenever I'm drawing a triangle, it always has to look like one of those pieces of the bow tie. So for example, if it was in quadrant 1, the triangle would look like that. Quadrant 2, it would look like this. Quadrant 3, it would look like this. And quadrant 4, it would look like this. So whenever you want to know how exactly to draw your triangle, sketch a little bow tie for yourself, and then that's always the way you're going to draw your triangle. Okay, and like I said, I'm going to revisit this multiple times, keep repeating it over and over. Now, what's the point of drawing this triangle? Well, once you've drawn it, you're going to label your side lengths. This is going to be your X side length because obviously it's on the X axis. Any vertical line is your Y side length because it's going up and down. And then we're going to call this R because it's going to be the radius of your terminal arm, right? So it's called the radius because you're pretending like it's in a circle, but it's just R. X is allowed to be either positive or negative depending on which side of the line you draw it on. So if it's on this side, it'll be positive, but if we were drawing it this way, it can be negative. Y can also be positive and negative depending on which part you're on, but the R always has to be positive because if you're drawing a line, you can't have a negative measurement of an actual line. It always has to be positive. And then based on this information, you can use SOHCAHTOA and actually figure out what the ratios would be. So sine theta is opposite over hypotenuse. And according to this, if I've drawn my theta over here, then opposite is Y and hypotenuse is R. Cos theta would be X over R because adjacent over hypotenuse. And then tan theta would be opposite over adjacent, which is Y over X. All of this right now without actual numbers probably is very hard to understand, but this is sort of the basics behind the calculations that we're going to do probably in tomorrow's class. So just remember these concepts and it'll make a lot more sense when we actually get to numbers. Let's try question number 1. Question number 1 says, the point P 6, 8 lies on the terminal arm of an angle theta in standard position. Determine the 6 trigonometric ratios and find theta. Okay, so how are we going to do this? Let's start first by just sketching out 6, 8. So I'm going to make my XY plane. And I'm going to say that 6 is, it's just a sketch. So 6 is approximately there and 8 is approximately there. So this point right here is going to be 6, 8. Okay, now let's read the rest of the question. So the point 6, 8 lies on the terminal arm of an angle theta in standard position. This means that your terminal arm is passing through the line or the point 6, 8. Now, if you don't want it to pass through, you can actually draw it directly on it, but it's going to look something like this. It starts at the origin, and then it's sort of going like this. I'm going to erase part of that. So this means that your like initial arm was somewhere there. We don't have to draw it, but if you wanted to, you could. And then your terminal arm is swinging around and it is definitely passing through the point 6, 8. We're trying to determine the 6 trigonometric ratio. So what we have to do with this is first we need to make an actual triangle. Look at the little bow tie shape that we drew over there and it'll tell you how to draw your triangle. You're going to make a dashed line going down. And your theta is going to be in there. And by the way, I should have mentioned that with the little bow tie structure. So every time you draw your little bow tie, the angles are always drawn in the inside of the bow tie. So whenever you're drawing your thetas, it's always going to be like in the inside corner of it. Okay, so let's do this example and then we'll probably stop there. How exactly are we going to figure out the trigonometric ratios? We need to fill out a little bit more information on this, and we can do that by figuring out x, y, and r. What is our value for x in this question? Yes, good. So the value for x, which is basically from the origin until the triangle, where the triangle starts, it's going to be the number 6. What is, and you know what, yeah, that's good enough. What is our value for y? It's going to be 8. And how do we calculate our value for r? This is a right angle triangle, so we can use Pythagorean theorem. Good. So let's go ahead and use Pythagorean theorem. R is the hypotenuse, so it's going to be r squared is equal to a squared plus b squared. R squared is equal to, it doesn't matter what a and b is, it's just going to be 6 squared plus 8 squared. R squared is equal to 36 plus 64 is actually just 100. And R is going to be equal to 10. Now, should I be writing plus or minus 10 or just positive 10? Remember, your R can only be positive. So in this case, you don't need to write plus or minus. R has to be positive. Okay. So now based on this information, let's go ahead and figure out the 6 trigonometric ratios. Let's start with sine theta. So sine theta is, they just want the ratios for now. So what would sine theta be? Opposite over hypotenuse, which would be, what's that? Y over R, yeah, and then we have actual numbers this time. So we're gonna go 8 over 10. Did everyone see where I got the numbers from? Okay, do we need to simplify it? Nope, you can leave it like that. Cos theta would be adjacent over hypotenuse, so it would be 6 over 10. And then tan theta would be opposite over adjacent, which would be 8 over 6. Those are the first 3 ratios. How do we figure out the other 3? Well, once we have this down, it's pretty easy. We just flip it around. So this would be cosecant theta is equal to 10 over 8. Secant theta is equal to 10 over 6. And then cotangent theta is equal to 6 over 8. The last part of the question says find theta. And if you're wondering which one do you use, you can literally use any one of these and you should get the same answer. So for example, if you use sine theta is equal to 8 over 10, just do the inverse, sine inverse of 8 divided by 10. And if we round to 1 decimal place, I get 53.1. Let's try it with cos theta. So do cos inverse of 6 divided by 10, which gives me 53.1. And then if you do the tangent, so tan inverse of 8 divided by 6, you get 53.1. That's proving it really doesn't matter which one of these thetas you use, they'll all give you the same answer of 53.1 degrees. And by the way, using the secondary trig ratios is useless because you'd have to change it to the primary trig ratios, so don't use those to calculate your answer. And then last but not least, oh no, actually that's it. So I'm going to stop there and we're going to start with this sheet next class. You don't have any homework, but if you want, just maybe review all the things that we talked about today. So we had started this topic yesterday. We're going to continue it today. I'm going to run through what we talked about yesterday really quickly. We started yesterday's class by talking about the 6 ratios that we've learned: sine, cosine, tan, secant, cosecant, and cotangent. We also reviewed the special angles, so the 45-degree triangle and the 30-60. All of that information you're going to need to know for your quiz on Thursday. And a reminder, you're not allowed to use calculators for that. All of your calculations will be based on the special angle triangles. So then after we reviewed all that stuff, we started talking about a ratio or an angle that can be drawn on a 360-degree plane. What that means is we needed to learn how to label our quadrants. We went over that. We needed to learn how to label our angles. So 0, 90, 180, 270, 360. And if it's negative, you're just going in a clockwise direction. And then we also learned what an initial arm and a terminal arm is. So we're going to talk more about that today. We did one example, which is this one right here, and we drew a terminal arm. We figured out what the different side lengths were, x, y, and r, and then we practiced doing sine, cosine, tan, and cosecant, secant, and cotangent. And we recognized that when we're trying to find theta, we can only use sine, cosine, tan, but any one of those is going to give you the correct angle of 53.1. So we're going to start on the second page today, and we're going to talk about what happens when you draw the different angles in the different quadrants, and what do the signs of the answers mean. And like I said, all of this stuff that's in theory can be super confusing until you actually get into the examples and put in numbers and see how it works. So bear with me with the theory stuff. When we get to an example, hopefully it'll make a lot more sense. So let's say I drew an angle or a terminal arm in quadrant 1. So it looks something, we're going to start on the top right-hand side, and we're going to start with quadrant 1. I'm going to remind you that yesterday I showed you this bow tie structure, which we're going to refer back to a lot. So if you want, you can go ahead and practice drawing it now. It's basically you draw a little XY coordinate, and then you make like a tuxedo bow tie that looks like this. And this tells you the way you're going to be drawing your triangles whenever we draw them in any of the quadrants. The other thing I pointed out was whenever we're labeling these triangles, we are always going to be putting the angles inside the bow tie, like kind of where the knot is made. That's where we're going to be putting our angles. So imagine we drew a terminal arm in quadrant 1. We've kind of already practiced doing this. And we have to make a triangle. So I'm going to make the triangle going down just a dashed line. And when I do that, it gives me a nice right angle triangle. So we can go ahead and label this right angle triangle. We're going to call this X, we're going to call this Y, and we're going to call this R. And then theta is going to be drawn right inside there. So now I don't have numbers. That's okay. We're just going to use X, Y, and R to figure this out. If I were to ask you what sine theta is, we would remember SOHCAHTOA. Sine theta would be opposite over hypotenuse. So it would just be Y over R. And the answer we would get when something is drawn in the first quadrant is it would be positive. So sine theta of an angle in the first quadrant will always be positive. Remember this? Tell them how important cast is. It actually comes up a lot. Cos theta would be X over R, and the answer would be positive. And tan theta would be Y over X, and the answer would be positive. So basically, any angle that you draw in quadrant 1, all of the answers for sine, cos, and tan will always be positive. So we're just going to write down all positive. And we're going to do this for angles in quadrant 2, quadrant 3, and quadrant 4. Okay, so let's go on to quadrant number 2. And like I said, we're going to do the same thing. For quadrant 2, the terminal arm is drawn from here to here, and theta is this angle over here. Now you're probably wondering, well, that's not what it shows in the bow tie. I'm going to get back to that. I'll tell you why exactly we do it like this. For now, all we need to know is our terminal arm is there. We're going to make a triangle that looks like this. And just for now, we're going to pretend the angle that we're talking about is inside the triangle. So we're just going to draw a little theta over there. Now here's the thing. For this triangle, are we going to have a positive X or are we going to have a negative X? Good. We're going in the other direction. It's going to be negative X. How about Y? Is it going to be positive or negative? If you're going up, it's positive. So this is going to be positive Y. And what did I tell you about R yesterday? What's always true about R? It's always positive. So let's figure out sine, cos, and tan theta. Sine theta would be Y over R. So it would be a positive value. Cos theta would be negative x over r, so it would be a negative value. And tan theta would be y over negative x, and it would be a negative value. So in quadrant 2, what is the only thing that's positive? Sine, cos, or tan? Yeah, so we're just going to write down sine, positive. Thank you so much. See you next period. Okay, there's this. I will put it here. Okay, go ahead and figure out the signs for quadrant 3 and quadrant 4. I'll do them up here and we'll see if we get the same answer. Oh yeah? Yeah, the calculus is a lot more algebra, right?
Like looking at it.
Yeah. And have you done physics?
No. Not for physics. But people who did physics way easier.
I agree, yeah, because they do so much vector. All right, you guys, so I kind of worked ahead, or I guess we were kind of working on our own. For quadrant 3, I drew my triangle as you can see it over there. And when I labeled my x, I remembered it would be a negative x, and my y would be a negative y, and r would be r. So looking at this, it seems that the answer for sine theta will be negative, the answer for cos theta will be negative, but the answer for tan theta is going to be positive. So if you're looking at the signs of this, what is always positive in quadrant 3? Tan theta. So I'm just going to write tan is positive. We're coming up with a really important rule after this step. I did the same thing here for quadrant 4. This is where I drew my triangle. X is positive, Y is negative. I figured sine theta would give me a negative answer. Cos theta would give me a positive answer, and tan theta would give me a negative answer. So what is always positive in quadrant 4? Cos. So cos is positive. Now, if you ask anyone who's done grade 11 math and then does grade 12 functions or anything, one of the things they learn about trig that everyone always talks about is the cast rule. I don't know if you've ever heard this, but cast, C-A-S-T, actually refers to what we just did over here. And the rule is pretty simple. It tells you that depending on where you're drawing your triangle and which quadrant you're drawing it, one of the signs will always be positive. So here is how we're going to be writing our cast rule. Every time we label something, this is what we're going to do. We're going to start from the 4th quadrant, and we're going to say this is C, this is A, this is S, and this is T. And that acronym cast tells you that cosine is positive here, everything is positive here, sine is positive here, and tan is positive here. And the reason behind it is sort of the activity we just went through. That's the reasoning behind it. But as long as you memorize cast and where it belongs, then you can very easily figure out the sign of anything in any quadrant. Again, theory, so we haven't practiced using it yet. It will make sense when we do questions, I promise. All right, questions about this before we move on? You're probably confused, and that's okay. Keep telling you that. I feel like that really helped for ambiguous case because you guys killed ambiguous case. So I think I almost need to hype up a topic before so you're really paying attention because everyone did, like, you did really well on that one. All right, one last piece of theory before we can move on to some more calculations is something called the related acute angle. And here is how I'm going to explain it. So just look up here, pencils down. We're just going to go through a little bit of theory. We've learned the 45 degree angle is 1 root 2, and we've learned the 60-30 angle is 1 2 root 3. Do you notice that all of these angles that we know are always acute? So we don't know anything greater than 90 degrees, right? Unless we use a calculator. So there's a little rule that when you draw a principal angle, a theta, that is over 90 degrees, our calculators break down and they will not work anymore. So what we need to do is we need to look at that obtuse angle and find a related acute angle that will give us the same answer as whatever the obtuse angle was. And in math, it actually works out really well. For every single obtuse angle, there is a related acute angle, and then we're going to use the acute angle to do all of our calculations because it's much easier. So how exactly are we going to figure out the related acute angle? In quadrant 1, whenever we draw our terminal arm, this angle right here is theta, And it just so happens that beta, which stands for related acute angle, and you can make a note of that, beta is called the related acute angle. In quadrant 1, whatever your theta is, your beta is as well. So your principal angle is your related acute angle. Can you think of a reason why that's true? In quadrant 1, what is the maximum degree you can have in quadrant 1? It goes from 0 to what? 90 degrees. So already the principal angle is acute, right? You don't need to do any calculations. Whatever angle you get there, it will already be acute. All right, you guys. So we just, sorry for the little thing, detour, or what a distraction. We just realized that in quadrant 1, theta is equal to beta. Now let's look at quadrant 2. When you have an angle in quadrant 2 like this, you are always going to draw your angle from the initial arm to the terminal arm. So your theta is now an obtuse angle. It's going to be an angle between 90 and 180 degrees. We've just established that obtuse angles don't work very well for our calculations and our calculators. So we need to find a related acute angle to that obtuse angle. And that is going to be drawn over here. So remember when I was showing you the little bow tie and I always said our angles will be drawn inside? That angle was actually referring to the beta angle. Okay. Now, how do we do the calculation? I honestly don't memorize the formula. I use logic. I know that from here to here, it's 180 degrees. So if I have 180 degrees in total and I have a theta, if I subtract those, I will get the little piece of beta, and that will be my related acute angle. Does that make sense? A little bit? Let's do 2 more examples and see if it makes sense to Kareem. For the third quadrant, we have a terminal arm there. We have the initial arm there. We always measure our principal angle, our theta, from the initial arm to the terminal arm. I'm trying to use as much vocabulary as possible so you guys can start to become familiar with it. So initial arm to terminal arm, the angle of rotation is called your theta or your principal angle. That theta is definitely obtuse. It's much greater than 90 degrees. So we need to find a related acute angle, and we're going to find that from measuring from 180 to the terminal line. How are we going to do the calculation? Again, don't memorize anything, use logic. You know from here to here, it's 180 degrees. If we take our theta measurement and we subtract 180, we will get this little beta over here. Okay, and then for the fourth quadrant, we have this final angle drawn here. So our initial arm is always on the X, and then here we have our terminal arm. We measure from the initial arm to the terminal arm like this. That angle of rotation, the principal angle is obtuse. So we need to find a related acute angle that will fit into there because that's what we're going to use for our calculation. And to do that, we know a full circle is how many degrees? Yeah, so this is 360 degrees. If we take 360 and we subtract the principal angle, we will end up with the little related acute angle, which is beta. You might as well. All right, so here is the explanation of everything again. The CAST rule, C-A-S-T. Some things to remember, your principal angle can be any angle between 0 and 360, but the related acute angle has to be acute, which means it has to be between 0 and 90. I have also drawn that little bow tie for you again that we're going to keep referring back to. And we're going to remember when we're drawing our related acute angles, they will always be in this position over here. Okay, we have officially learned all the theory we need to. Let's get into some calculations. This will be a little bit of a longer class, but that's okay because we're having fun. I have labeled the different types of questions we're going to do this entire week as type 0, type 1, type 2, type 3. I find that when we sort of split them up into different types, when you get a test question, you can identify what type it is, and then you'll know what strategy to use. So there's a different type for every single thing. I don't know what you guys are talking about. Type 0, finding the ratios. So question number 1 says, what are the exact primary trig ratios for the angle theta represented by a terminal arm that goes through 8, -5, calculate the value of theta and draw the terminal arm and label the side length. We actually had a little bit of a taste of this last class when we did like that question. So we're going to do it one more time and see if we can try and figure out what is happening and also solve for some of the angles. So the first thing I'm going to do is I'm going to identify where 8 comma negative 5 is. 8 is approximately here, and let's say negative 5 is approximately there. So 8 comma negative 5 will be, let's say, over here. Our terminal arm is going through this point. So that gives me a little bit of a hint that I need to start at the origin and then just go through the point 8 comma negative 5. So I'm going to extend this and then I'm going to erase it because I feel like that's much easier. Okay. Now what I'm going to do is I am going to draw my triangle. I'm going to refer to the bow tie, and I know because I'm in quadrant 4, I need to draw my triangle like that, and I need to label my angles accordingly. So what I'm going to do is I'm going to go ahead and make a line that is going up. And I'm also going to label this point 8 comma negative 5 so we remember. Actually, we don't even have to do that. If you wrote it in on the sides there, that's fine. So this was 8 and this was negative 5. Okay, so what is our value for x in this question? Good, and what is our value for y in the question? Good, so go ahead and put that in. Our value for x is 8, our value for y is negative 5. How are we gonna figure out the value for r? We're gonna go ahead and use Pythagorean theorem. So we know r squared is equal to a squared plus b squared. R squared is going to be equal to 8 squared plus negative 5 squared. R squared is equal to, you can actually, because the question says exact, we're not going to make it into a decimal. We're going to keep it in its radical form. So R squared is equal to 89. And that means R is going to be equal to square root 89. Can we simplify square root 89? I don't think you can. I don't think it's going to reduce to anything useful. So we'll just keep it as r is equal to root 89. So I'm going to go back to my diagram and I'm going to write in root 89 over there. Okay, we're kind of getting to the answer. We also need to label our theta and our beta. So what do these letters represent? I will tell you them again. Your theta represents the principal angle. So that's the angle from the initial arm all the way to the terminal arm. So you're going to draw that from here, shaking too much on this. From here all the way over here, and you're going to label that theta. Now, is theta an obtuse angle? Yes, we can't do our calculations with that. We have to find a related acute angle. And we're going to draw that related acute angle into this part right here, and we're going to label it with a little b that stands for beta. The question wanted all of the side lengths. We've labeled them 8, negative 5, root 89. They wanted us to draw the terminal arm. We did that. And now we also need to figure out the exact primary trig ratios. So they're not looking for secant, cosecant, cotangent, just sine, cos, and tan. So on the side over here, I will go ahead and write those down. Sine theta is going to be, okay, now here's the thing. Are we going to use theta or are we going to actually use beta? Because our triangle is this over here. And the theta is irrelevant. So although I'm saying sine theta, it's actually going to be sine beta. We're going to do all of our calculations using the beta degree. So we're going to go sine beta or theta is equal to opposite over hypotenuse. It's going to be negative 5 over root 89. cos of that angle is going to be adjacent over hypotenuse. It's going to be 8 over root 89. And tan of that angle is going to be opposite over adjacent. It's going to be negative 5 over 8. When you're trying to solve for that little beta, you have to actually, you can pick any one of these trig ratios, it doesn't matter, but you're not allowed to include the negative sign in your ratio. If you do that, it messes up the calculation. So let's say we were to pick the easiest one of these is probably tan, right? If we're trying to actually calculate what theta or beta is, we're going to have to change that to be tan beta is equal to positive 5 over 8. So we're going to make a little note and we're going to say whenever we're trying to calculate for beta, never include the negative sign in the ratio. Okay, so again, you have sine, cos, and tan, that's fine. We're actually trying to solve for what theta and beta are. The first thing we're going to do is try to solve for beta, but when you're using one of the trig ratios, you either pick the positive one like cos, or if you pick sine and tan, you cannot include the negative sign that goes with the ratio. You're going to have to drop that and then figure it out. Now, could we have just gone cos inverse? Yeah, we're actually going to try it for all of them. So let's try cos inverse of 8 divided by root 89. Tell me what you get. 32. Okay, let's try it for sine. So do sine inverse, but drop the negative sign. So 5 divided by square root 89. You should get 32 as well. And then we're going to do the same thing for tan. Tan inverse, drop the negative sign. So we're going to go 5 divided by 8. Which is also going to give us 32 degrees. So it doesn't matter which one of those you use, just make sure you're using the positive ratio for all of them. And we can now write down that beta is equal to 32 degrees. Okay, we're not done. We've just figured out beta. Can we figure out theta if we know what beta is? And what's the calculation to do that? Excellent. So theta is going to be 360 degrees minus 32. And that's going to give me an angle of 328 degrees. So our theta is equal to 328. Our beta is equal to 32 degrees. And our 3 primary trig ratios are there, and our diagram is there. You're going to practice doing this with the homework questions I've given you at the bottom, questions 2A, B, C, and D. I've included the answers. I can't promise the answers are all correct. Actually, if you find a mistake, let me know. But that's really all the theory we're going to need to know and type 0 type of questions.